Hello and welcome to this video about the readers and writers problem. So in this video we're going to go through these points here. First, the introduction to what is the actual problem and something about what are the rules that we must follow. And then we will look at the various types of solutions. First, a little introduction to what I call a director. I don't know if that's an official name, but that's what I call it. And then we have three solutions: the reader's preference, the writer's preference, and a queue. And I will do a coding example for the reader's and writer's preference, and we will talk a little bit about what starvation is, a problem that we need to consider when we do the reader's writer's problem here. The last one I will explain the idea but not go through the coding for it. And the second coding example is probably a bit shorter because it's very similar to the reader's preference. So these are the points. We'll start with the introduction to what the problem actually is, what we're trying to solve here. So let's assume that we have some kind of shared resource. That might be a database. It could be a file. It could be any kind of shared resource, maybe an array list, or in my examples it will just be an integer or string or other type of collection or whatever. Anything that multiple threads wants access to, and these threads will either read the data or they will modify the data. So we have two types of threads. So in my example I'll just use a file here, and we have two types of threads. We have threads that wants to read the data, and we have threads that wants to write the data, modify it some way, either delete or add to it or modify existing data. So those are the two categories. Sometimes a thread might want to read something, and other times the same thread might want to write something, but we divide them into these two categories. So depending on whether that thread wants to write or to read, it will put on a different hat, so to say. So the reader threads here, they will just look at the data. They're not going to modify it, they will just look at it and say, okay, that's interesting, now I know something new, or whatever. And we can have as many reader threads as we want to. They can all read the same data because they're not modifying, so they're not interfering with each other. So we don't really have an actual limit on the number of readers. However, for our writers, only one writer thread can be active at a time, because it's modifying something, and we cannot risk that two threads are trying to modify the same data or write in the same file. That will just potentially corrupt it. When this writer is finished, the other writer can then get access and do its thing, so it can now modify whatever data it needs to do. And if we have readers already reading it, other readers are allowed to also come and read it by default, or well, we will use different solutions, so this is not always true, but in general, if there are readers, then more readers should be allowed to come. But if there are currently any readers reading the data, then a writer thread is not allowed to go and modify it at the same time. So we end up with one writer at a time or multiple readers at a time, but never more than one writer, and never a writer and reader at the same time. So these are the two that are allowed. So our goal is mainly to make sure that we control the access to this shared resource and ensure that these rules are followed. So that's the introduction to the problem. A shared resource, some threads want to modify it and some threads just want to read it, and we need to control access to that shared resource. So let's take a look at the solutions. How do we actually fix this? One approach would be to just synchronize everything. Whenever you want to read something, you just synchronize that method. When you write something or modify something, you synchronize that method. But that may slow down our program significantly. there's no problem having many readers at the same time. So if they were to go just one at a time, that would slow down our problem. So there's no need to make a strict restriction like that. So instead we introduce what I have called my director. It's a class that controls when a writer is allowed to write and when a reader is allowed to read. So it keeps track of who gets access to the resource. Sometimes it will allow the writer to get access, and sometimes it will allow the reader to get access. So this class is the class that controls access to the shared resource. I call it a director. It is a monitor, and in Java a monitor class is just a class where all our methods are synchronized. So remember the monitor keyword, everything's synchronized. So that's the sort of general approach. We need some kind of class to control the access. And we can write that class in various ways. I have 3 suggestions here: the reader's preference and writer's preference, and then a type of queue approach. We will start out with the reader's preference. Or before we get to that, let's just get a quick overview of what the solutions actually are. So the reader's preference is just that we will try to make sure that readers get access as soon as possible. And that may mean that the writer will have to wait a lot longer. So we use this approach if it's a lot more important that readers get access to data rather than we update that data. The next approach is the writer's preference, and this is, well, the opposite. We make sure that the writers get access as soon as possible, so that our data is as much up to date as we can, as we can do, and the readers will then potentially have to wait for a long time. And the third solution is a more fair approach. We're using some kind of optimized queue. So whenever you want to access the shared resource, you get put in the queue. The director will then take the next one out of the queue, and if it's a reader, it will also check, is the next one also reader? Okay, you both get access. And then the next one, okay, that's the writer, so only you 2 guys get access. This one does not get access yet. So if you have multiple readers in a row, they all get out. Otherwise, it's just one writer or one reader. That's the idea. So those are the 3 approaches: a reader's preference, a writer's preference, and a fair approach using a queue. And that was the introduction to the solution. So now we will get a bit more specific. We will take a look at the reader's preference approach. So these are the rules, right? All the readers can read at the same time. That's the given from the initial problem statement. There can only be one writer at the time. That's also from the original problem. And in this case, a writer will have to wait until there are no active readers. That's also sort of given through all the solutions. And we have that a reader will wait until the writer finishes. So if a writer is currently writing and a reader wants access, it will have to wait. Now here's the preference part. That's the point number 5. If both readers and writers are waiting, readers will get precedence. So if there is a writer currently writing and a reader waits to get access and the writer waits to get access, then we will make sure that the reader will get access before the waiting writer will get access. So we want to get access for these as soon as possible. Okay, so the mechanism we will use is the guarded block, the while loop with a wait inside. We've seen that before, I hope. Otherwise you're skipping a video session. And my director will then use this mechanism to either give access or make a thread wait. So in order to get access to a shared resource, these are the steps that we will use. A thread will first request the access, and if access cannot be granted, it will wait. if it can be granted, we move on to the second one. So in the second point, it has been granted access. You are now allowed to do whatever you want, either read or write. So it can perform that action. You can modify the shared resource as it wants to, or read from it. And when it's done, it has to say, okay, now I'm done. So I no longer need access, and then others can get to the resource, right? Get access, actually use that access, and then release the access again, say I'm done. So these are the 3 steps. And in order to perform those steps, we need to have at least this kind of functionality. We must be able to acquire read access. We must be able to say, I have now released read access. We must be able to acquire write access, and the writer will have to say, I'm done writing, so I release my write access. So obviously for a reader, the steps will be acquire read, do the actual read, release the read. For the writer, it will be acquire write access, do the actual write, and then release the write. All right, so in my example, which we are 1 slide away from, I will just have my shared data to be an integer. It could be a list or a file or whatever. It doesn't really matter. As long as I have access, I can do whatever with that shared resource, whatever I want to. And in my case, I just want to increment it. I could write an integer into a file or whatever. That's not relevant for the problem. So my readers want to read it and then print out the value, and my writers want to increment this integer. So we will do a programming. Well, I will, maybe a program along, I don't know. And I'm going to use the reader's preference first. All right, let me find IntelliJ. That was here. I have a reader's preference package. Let me create a Java class. I will call it reader's preference to shared int, something like that. And so I need to make sure that I keep track of, are there any active writers? So I need a private boolean active writer. I need to keep track of how many readers are currently reading, because I cannot just say there is an active reader. I need to know how many. Well, I guess it's relevant only if there are 0 readers or more than that. But I still need to keep track of them so I can figure out when there are 0 readers. So we will say private int active readers. And I also need to keep track of how many are waiting, so that if there are waiting readers, if they're waiting to get access, then I will not grant access to the writer. So I also want to say int waiting readers. Come on. There we go. And then I need the shared resource, private int, shared int. And that's probably all I need for now. So these are by default false, 0, 0, and 0. So there's no need to set them through a constructor, and I don't need a constructor for anything else right now. So I don't need to do that. Okay, so we will first create the method to acquire the read. Let me just say acquire read. I'll do like that. I will say public void release read. So these are the methods that I need, right? To get access. Acquire write. I need to release write. And I need to have some method to interact with the shared int. So I will create a public int read int. I can just create that method right away, shared int, like that. And public void increment int. Like this is shared int plus plus. Right, so these are my read method and my write method. And I could obviously have some more interesting thing down here if I had a file or a database or a list or whatever. Right, but these are not that interesting. So we'll do the acquire read first. Now, when I get to the acquire read, I want to say that because I have, when a thread calls the acquire read, it has not yet been given read access. It's just saying I would like to get read access as soon as possible. So it is initially waiting, and then we will check, can you actually get access to the read, get read access to my shared resource. So I can get access as long as there are no active writers. So if there is an active writer, then this becomes true, and that means I cannot move on further, and I can only proceed from this while loop if the active writer is not, or if there is nothing, right, if it's false. So in this case here, we want to wait, and I cannot call wait without having a synchronized method, so we will do that. And I also need to surround this with try catch like that, and we don't expect to wake that up, and I will just rename this to ignored. IntelliJ likes to do that. In any case, we're not doing anything with it. Okay. Now, whenever you want to call the wait method, it must be done inside a synchronized method. And remember, when I call, so a synchronized method means that in order to call it, we will have to acquire the lock of the instance of this class. And the wait method, when I call this, we will release the lock so another thread can acquire that lock. We can then wake up from the wait, or stop waiting when we get access to that lock. So at some point, we will either automatically stop waiting, or we will get a notify call to my thread here, and we'll check again, is there any active writers? If it's true, there's still an active writer, we will just wait again. If it's false, then, well, we're no longer waiting readers, right? There are no active writers, so this is where I get to the point that now I want to actually grant the access. Up here, we're just waiting for the access. Now we're done waiting, and we want to grant access, say now you're allowed to read. So instead of having a waiting reader, we now have an active reader. So I'm keeping track of how many readers are waiting and how many readers are actively reading. All right. Then at some point, the reader will first acquire read. It may have to wait. If there is an active writer, when the active writer is done, it may require acquire read access. It will then do the read, and then it will release the read. And so I need to say here that active readers minus, and if there are 0 readers left, so we say if active readers is equal to 0, then we want to notify all. We're now saying there are no more readers actively reading the shared int, so if there is a writer waiting, it can now get access. All right. We need to do something similar for the acquire write. We will say, when can I acquire write access? Well, I can do that if there's no active writer, because there can only be one writer at the time, and if the active readers is equal to 0, and if the waiting readers is equal to 0. And this should not be an and, because that will never be true. Maybe it will. But if there is an active writer, we have to wait. If there are active readers, we have to wait. If there are waiting readers, we have to wait, because that's the reader's preference. If both a writer and a reader are waiting, we will say the reader should get access first. So here we wait. And that means I have to synchronize the method. Otherwise you will get an illegal monitor state exception. So if you see that, it's because you do not have a synchronized method and you're trying to wait. And we will just say yes, ignored, and I'll collapse that. yeah, and once we are done waiting for the access, we can actually get the access. So we say active writer is equal to true. And that should be it. So now my writer has access and it is active. And at some point it's done, and we will say active writer is equal to false, and we will now notify all, saying someone else can get access. And that should actually be it. For my class here, we can acquire read with a reader's preference. We only check if there is an active writer, not anything else. We can acquire write with reader's preference, because we cannot acquire write if there is an active writer, or if there are active readers, or if there are waiting readers. And then we can release the access, and we can, oh, that's this part or that part, and we can actually modify something. So let's create a small program to run this. We'll say new Java class, run example, and I need a main method. And here I will create a reader's preference, like that, and like this. And I want to have three writers. We'll do like this, new thread. So I'm creating a new thread, and something broke. There we go. And we want to do something inside that thread. We want to say rp acquire write, rp do the actual write, increment in, and rp release write. Right. So these are my three steps that I have to do. First, I will get write access. We may have to wait here. When we actually acquire the write access, it will continue to the next one and increment the int, and then we will release the access. And then we just say, I want to sleep for a little bit here. Sleep 100 milliseconds. I don't know. Do I have an random? Is that it's not static in Java, so we will just say random. Yeah, that one. New. Come on, random. Yep, and I want to sleep for some time, something like this. Random next int. So between 50 and 100 milliseconds, and I surround with a try catch. Like that. Okay, so that's my reader thread. I also want my writer thread, sorry. I want a couple of readers. Let's say 10. And we will also get access to that one. We will acquire read. Read int, like that, and that returns an integer to me. We'll just say results, and we will print out. Oh, I need to put this into a thread, sorry. New thread dot start, like that, and we give it a lambda expression like this. So this is what the thread should do, and we put that in here, and then we are printing it out, result. And maybe I can do this, reader I don't have access to that. Can IntelliJ move into anonymous object? Yeah, okay, yeah, interesting hack, that's fine. And then I need to remember to release read. There we go. So I acquire the read, I do the actual read here, and I release the read again. And that should be almost it. We also want to sleep a little bit here. I will sleep a little longer because catch. It wants to rename it. I'll just do that. I don't like the annoying yellow or you have a warning, there's something wrong with your program, but not really, but whatever. And let's see what happens. And we're compiling, we're waiting. It's going to be so exciting. I just pause. And here we go. I think. And that was super not very interesting. So first I get an illegal monitor state exception. That probably means that I have forgotten a synchronized keyword somewhere, and I need to, whenever I want to use notify all, I also need the synchronized. So that means I put it down here as well. Forgot that, sorry. All right, and then I only see this printed out once. And why do I do that? Well, I don't have this in a while loop. So we will just surround with the try. So that was Control Alt T, and I will surround with a, that did not go as planned. Control Alt T, surround with the while true. That's good. We want to do this forever. And this part also Control Alt T while true. Let us give it another go, see what happens now. And we print out a bunch of zeros. 0, 0, 0. So it seems like it's never really being incremented. And that's actually the next topic. Let us just modify this a little bit. Let's try again. It's still 0. Let us remove this part. We just do that, and we say \t, do that a couple of times like that. Okay, let's see what happens. Do I actually get to this point? I do start that thread. This is interesting. Hang on. Alright, so here if there is an active writer, then this is true, but I'm negating it, so it's false. So as long as there is not an active writer, I have to wait. So initially there's not an active writer, and that just means I wait forever. Let's see if that fixed anything. And I cannot get write access if there are more active readers than 0, or if there are more waiting readers than 0. I think I messed up this part. Right, so I am allowed to write if there is, well, I have to wait for the write access if there is another active writer, if there are currently active readers, or if there are waiting readers. That was a bit annoying. Let's see if that I hope I don't confuse you too much here. Let's try again. Okay, so now I actually get something here. We increment a bunch of stuff, and the numbers are printed out many times. Okay, so let's get back to this part here where we say, okay, writer, you have to wait for a little while, 100, and you guys, you don't have to wait. And let's see what happens now. Okay, I do get access for my writer. That was actually not what I wanted, because my writer is, you know, that we have the reader's preference. So what I wanted to show is that if I have too many readers and they just keep on coming, then my writer will never get access. And it's not really going exactly as planned. So let's try and add some more readers. I have 55 threads, that's probably okay. I'm sure my super old laptop can actually handle that. We'll see. It's still incremented, okay. All right, so my readers are no longer sleeping, they're just working around the clock. So I get the 3 increments initially because my readers have not started, but now it's just running and my writer is not getting access to it because I have too many readers and they want access all the time. So this is what we call starvation. Something is happening in the system, but there are certain threads which are never allowed to proceed. So they are being starved from their getting access to the resource or whatever you want to call it. So that's the first example, and let's get back to the presentation. And that was the live coding part, and we have checked out the reader's preference approach, we've done the coding example, and I've just briefly mentioned starvation. So if I have too many readers and the writer is waiting and the readers just keep coming, so we have a reader is getting access and other readers are coming, and some may leave but there are still active readers, and my writer is just waiting here. Will it ever be my turn? But no, it will not. You're just stuck waiting forever. Right. So we might have a starvation problem here. It never gets access to what it needs. So that's the starvation. And right now in my current setup, the writer is starving. So in order to fix that, we could say, let's try a writer's preference approach. We want to make sure that writers gets access as soon as they can. So the idea is that all the readers can still read at the same time. A writer will have to wait until there are no active readers, and a new reader cannot get access if there are waiting writers. So that's the preference part, right? So I might have 2 active readers, and my writer goes, "Hey, can I take a look at that stuff?" And it has to wait, and then a reader comes along, and in our previous setup it would just get instant access because there are already readers, so it would be like sure, join us. But now, because there is a waiting writer, the waiting reader here cannot get access, right? So it has to wait, and at some point these are done, and then my writer can get access, and it will do its thing, and then afterwards the reader may get access again unless a new writer comes along. So now we have to keep track of how many waiting writers we have, and the reader will wait if there are active or waiting writers, and the writer will wait if there are active readers or waiting or active writers. So no longer waiting when there are waiting readers, and the reader will have to wait now if there are waiting writers. So we are just modifying the conditions a little bit. So I'm going to copy most of the code, and let me just do a new package, and we call it writers preference, and I want to move that, refactor, move, because I don't want it inside here, I want it there. Yeah. And I will take these 2 and copy here. So this one. Now the idea is the same. I still need to have methods for acquire read and release, and acquire write and release, and to actually access the resource. The only change is when do we have to wait? When do we have to wait? So I need to keep track of how many waiting writers do we have. We say private int waiting writers, like that. And a reader will have to wait if there is an active writer, or if there are waiting writers, right? If the number of waiting writers are more than 0, it will have to wait. And I don't care about these anymore, the waiting readers. Let me just comment them out. I don't think I care about them. Waiting readers. There we go. We still keep track of how many active readers we have. When I release the read access, we have to count them down and check, is it 0, then we can notify and say now there's room for writers. For the acquire write, we will have to say if there is an active writer, we have to wait. If there are active readers, we have to wait. But we don't care about any waiting readers anymore. And it's now active. And when we release it, it's false. And we notify that we have released everything. So I think that's actually the only change we need to make. And let's just run the same readers preference. I'll just rename this to call it writers preference to shared int. And we'll see, did this one, yeah, that changed, that's good. Did I mess up this one? It's still readers preference, okay. So now I have a writers preference. And before, when I ran my program here, we saw the starvation. The writer never got access because too many readers wanted access. So let's try and see what happens now. And it's running, and it's not going entirely as I expected it would. Hang on. That's probably because I'm not counting the active, the waiting writers. So we don't care about the waiting readers anymore, but this one is gray, it's never modified. So when we acquire write here, we say waiting writers ++ and waiting writers -. So we're now keeping track of our waiting writers. We need that as well. And let's try again. Let's see what happens. Writers preference. All right, it's being incremented. So my writer is no longer starving. If I modified my example here and had a bunch of writers and didn't make them sleep and had a few readers, we would just see the opposite thing, and that would be my readers might never get access to the resource, and so we would have reader starvation instead. So either approach can cause problems if you're not careful, or if you need to evaluate the ratio between readers and writers, I guess, or you could elaborate on this and check. Sometimes I have a third approach, well, a fourth, I guess, which I called balance, and it would also check if there are more waiting writers than waiting readers, then we would allow writers in, and if there are more waiting readers than there are waiting writers, then we would prefer the readers. Right. So whoever has the most waiting should get access. So that's a more balanced approach. It still may not actually solve our problem, so some threads would still get through on either side, but we cannot guarantee that all reader threads will always get access. If there are many reader threads, then potentially one of them could just starve because all the other reader threads are getting access all the time. So these are the very simple solutions, and you can then elaborate on them as you see fit. So in this case, we may have reader starvation if I have the writer's preference. So a reader's preference which may cause writer starvation, a writer preference which may cause reader starvation, and then we have a queue approach which will make sure that everyone gets their time, but it might be a bit slower because we don't have nearly as many readers at the same time. So Let's just check out what the final one here is about. I'm not going to program it. You can do it in your assignment if you feel up for the challenge. I haven't seen it done yet, so mainly I include this as a thought experiment and maybe a challenge. So here's the idea. I have a shared resource, could be my integer. In my case, here's a file, and my director, my class, has a type of queue. And initially 2 readers wants access, and my director will just say, okay, what's the first one? Well, it's a reader, so you get access. What is the next one? That's also a reader, so you get both access. And the next reader comes, and we will see, okay, there are already active readers, so that you can just get access. Now we have a writer. It has to wait. More readers are coming, but this one is the next in queue, so these readers will not get access even though there are active readers. They will have to wait their turn. At some point this reader here is done. My writer can proceed. It will do whatever it needs to do. It will finish. We will take all the readers here at the same time, and again, I have some readers further down the line, but they are not next, so they are not allowed to proceed. And these guys will finish, and my writer will finish, well, one after the other. We still only have 1 writer allowed at a time. And when it's done, my reader will get access, and these 2 still have to wait because they're not next in line. We have a writer waiting. So before we get to that one, that's the sort of fair approach. We have some kind of queue. Now my colleague suggested a type of queue similar to what you do at the, post office or bakery. You just, whenever you get in here, you draw a number, and then that is a way to keep track of the queue. So whenever you try to acquire access, you're given a number, and then when you are notified about waking up, you will check, is the current number in the queue equal to your number? Then you're allowed to go in. So it got a bit vague at the end here, but I don't want to spend too much time on it. It's sort of on the border of what's curriculum. So if you're up for the challenge, you can try this. Either do it with a queue collection or some kind of number system. Otherwise, for the assignment, you can just use either of the previous approaches. And that's all for now. Thank you for watching my video about readers and writers problem.